and electronic courses, no? Basic, advanced, and electronics, no? However, in the next coming classes, we are going to apply, and we are going to learn a little more electricity, but more applied. For example, the next coming class in January is diesel. In diesel, we are going to use a lot of DC current, because we are going to understand the harness of a diesel engine, the computer of the diesel engine, a lot of tips, a lot of secrets to solve the problems in the middle of the ocean, good for captains, for engineers. That will be nice, because it's a special secret, how to start the engine with no computer, but only with this and this. I am going to explain. How to recover an engine that was seated for 10 years. How to restart the engine again. That's nice. And after diesel is two classes. In diesel, we are going to use a lot of electricity and electronics, with the sensors, with the codes, how to check the sensor, make a jumper in between the signal and the ground, and between the ground and the positive. And it's a lot of electricity. You need good tools, excellent tools. For that reason, we are going to refresh quickly how to use those tools. And next class is gasoline. In gasoline, more electricity, more electronics, because today the engines are more sophisticated.
Gasoline engines have more electronics.
Yeah,
than diesel.
Yeah, a lot. I have a history about that. Is the Chevy pickup 1950, 1951. The Chevy.
Okay.
The pickup.
There's a 350 engine.
And the Chevy Bel Air, the Chevy 55. Nice.
Okay.
55, 56, 57, nice car, no? The engine of those cars, the engine of the Chevy Bel Air, is the famous Chevy 5.0, no? The 305 and 350.
350, right.
Yeah. Those are the same, not the same. It's identical. It's the same engine that you have in the Mercruiser engines for inboard boats. It's the same engine. It's Chevy 305 or 350, no? But if you check the engine of the new Mercruiser, you say, no, this is not the Chevy, or this is not the engine of the Chevy Bel Air of my grandpa. That's impossible. Yes, it's the same.
It's like the old one. It's not like the new one.
It's exactly the same piston, the same connecting rod, the same block, the same, exactly the same. You can order the new Mercruiser engine carbureted or injected, because some boat owners, some captains love it, carbureted engines, because it's easy to fix it. It's easy to clean the carburetor. It's easy to clean the fuel pump. It's easy to solve problems in Bahamas, in the middle of the ocean. With electronics, it's more complicated, because you need a lot of tips, and in some cases the scanner, in some cases special equipment. But it's the same engine, no? Incredible. And the technology is, no, my friend, in my opinion, if you ask to me, the efficiency is exactly the same. I was checking in internet some days ago advertisement about the Chevy Bel Airs and the Chevy Suburban 1950, and the fuel consumption is exactly the same like the Chevy Silverado and the Chevy Impala of today.
Right.
Exactly the same. And I said, what is the advantage? What is the technology? Nothing. It's absolutely nothing. It's nothing. The difference is that the new engine have 1 million of sensors additional.
More emissions.
Yeah, the catalytic converter, that's the only difference. But the rest is more complication. More complication because the old engines are too simple. You have a spark here, you have fuel, engine, the engine start. Today in the new one you have a spark, you have fuel, and you don't have nothing. You need a lot of more signals, more signal from the computer. It's more complicated. But okay, we are going to study that technology because this is the technology of today. I am an old school mechanic, and I try to do the comparison all the time to demonstrate to you that everything is simple. That this is my secret in my classes. Demonstrate that everything is simple. It's not complicated. The people try to complicate. No, my friend, it's not complicated. Current is simple. You have positive, you have negative. Yeah, that's it. In AC, you have the neutral, you have the ground, and the hot. Finito. No, my friend, don't try to complicate. I don't understand why the people is complicated. You check in internet the definition of Hertz. That definition, you need to go to NASA to understand. No, my friend, frequency is RPMs. That's it. It's the amount of cycles in 1 second. Finito. Oh, no, I don't understand. Don't try to be complicated. Try to be simple, and you will solve it every situation.
Simplify, right?
That's true, my friend. Try to be simple. Complicated, no, my friend. Remove that pump, clean the pump, and put it back. That's it. No, my friend, don't be complicated. Okay? This is the idea. This is the idea that I want to transmit to you for your future. Okay, after that, the gasoline engines, we have transmissions. And this is another wonderful class because this is a class where I integrate a lot of concept of hydraulics because the marine transmissions are a combination of the automotive manual transmission, you remember? Mm-hmm. With the automotive automatic transmission together, and this is the marine transmission. The marine transmission is a combination of both of them. For that reason, in my book of transmission, I start with the manual transmission, the clutch, the friction plate, after that the automatic transmission with the torque converter, the body of valves, and after that the marine transmission. When we finish the automotive transmission, you understand the marine transmission easily. It's too simple. This is a nice class. And in that course, we are going to talk about the conversion. The conversion of gas and diesel boats into electric boats. Why over there in that course? Because I want to explain one simple way to convert a boat. The people ask to me every day, Mr. Lopez, I have this boat with a couple of inboard gasoline engines, Mercruiser. I want to convert my boat into electric boat, but can I use the same transmissions with the new electric motor? And the answer is yes. Yes, we are going to replace only the engine. Only the engine. And we are going to put an electric motor. AC or DC. This is AC, the recommendation, 3-phase. No? And we are going to use the same transmission. Oh, nice. Of course, we need to create an adapter, a plate, in between the transmission and the electric motor, where the clutch is located in the actual gasoline engine. And with that coupling, with that adapter, you pass from the electric motor into the old transmission. Yes, for that reason, in that course, I am going to introduce the hybrids, the fully electrics, because this is the moment. I am creating a new book, a new course dedicated only to electric and hybrid boats. Probably in a couple of, in 6 months, I have that course as part of the program. In this moment, it's not part, but I have all the theory in that course, in transmission and gas. Okay, this is the next semester. It's basically from January to May, June, no? 4 courses. When we finish those courses, you are ready to work in engines and transmissions. When you finish that group of classes, all of my students find immediately a good job in Pantropic, in Caterpillar, in Detroit Diesel, in Wärtsilä, in RPM Diesel. Why? Because we are going to visit Caterpillar, and we are going to visit Detroit Diesel. And they hire normally 4 people, each company, 4 or 5 people of this class. For that reason, a lot of my students, you visit Detroit, a lot of people working over there, they were students of this program. And also, if you want to work in the gasoline side, we are going to recommend good companies to work in gasoline, if you prefer gasoline. The same with transmission, no? At the end of the gasoline, diesel, and transmission class, the majority of the students will find jobs, good jobs, with good salaries, with excellent salaries. After that, in the summer, we are going to take auxiliary systems. This is another, for me, a wonderful course. It's hydraulic systems, it's bow thrusters, steam thruster, pasarela, hydraulics, freshwater system, sanitation system, and fire suppression system. Is that course. After that, air conditioning. This is another world in the marine business. I love it, air conditioning. This is another corner of this business where you can make a lot of money in air conditioning. After the course of air conditioning, we have corrosion. This is, in my opinion, one of my best sellers. I sell every day, I don't know how many electrical books and corrosion books. The corrosion book is, and courses of corrosion. This is a class that I recommend, especially for people that in the future want to be a surveyor, an inspector. This is a great class. This is for captains. Corrosion is very, very important. All the problems, 100% of the problems in a boat, of course, are electric problems and corrosion problems. The life of the boat depends of how is the bonding in my boat, how is protected my boat, how is clean my boat, how is dry internally my boat, the humidity is the enemy. Yeah, that course, corrosion, is my best seller. And the last course is composite materials, outside with Danny. Okay, this is basically the program. And as you see, of course, in corrosion, we are going to use a lot of electricity, and chemistry. You will be a doctor in chemistry. For that reason, I have the periodic table. Okay, let me explain why. Because we are going to demonstrate that, of course, if you have humidity and you select the materials no marine grade, this is the step number 1 to produce corrosion. Now I have a lot of Home Depot metals, a lot of Home Depot wood, this is not marine grade, my friend. For that reason, it's corroded here. That's number 1. Number 2, I have a lot of leaks of humidity in my boat. The bilge is full of water. That's number 2. You have too much humidity in your boat. Your boat is not dry inside. That's very important. And number 3, this is your AC panel and this is your DC panel. Wow, who did that? Oh, a friend of mine in Hialeah. Oh, wow. This is you have a lot of leaks of current. For that reason, when you have dissimilar metals together in contact with humidity and current passing through the metals, all right. This is why the first step when you try to solve corrosion problems in a boat is identify if in the DC panel or in the AC panel I have leaks of current. And this is the most difficult part. Identify where is the leak. In what point is the leak? Is here? Is here? I have a leak, 100% sure. And I am going to explain more tools that we are going to use in a corrosion and different procedures to identify leaks. Basically, there are 3 procedures. The procedure with the arms, with balls, and with arms. I love it, the process with amps, because you know how much is the flow of amps through the ground. How much should be the flow of amps in regular conditions through the ground? Zero. 0.003. Practically nothing. And we are going to demonstrate that if you have more than 0.1, more than 0.001, 1 milliamp, more than this, that's not good. For the people, 0.001 is nothing. No, it's not nothing, it's a lot. And we are going to demonstrate both that they have a constant flow of amps, 3 amps, 2 amps, 1 amp, it's a lot. Constantly flowing through the bonding. That's not good. Yeah. We are going to use a tool. The name of the tool is the silver chloride electrode. We are going to check different type of boats, both with the hole in fiberglass, both with the hole in aluminum, both with the hole in carbon fiber, and what type of anodes should be installed in each type of boat depending on the water. That boat will be used in salt water, in fresh water, in brackish water. Depending of the water is the selection of the anode and the selection of the hardware, the balls, the screws. This is part of the table that I
Can I
have.
ask you a question? I just came. Why is it that a plastic, what do you call it?
Through hole?
The through hole. Yeah. Why is it a plastic-bodied one can work in fiberglass only in fresh water?
Yeah, this is a long theory, but this is part of that class. Why, in some cases, the name of those plastic fittings is Marelon. It's a reinforced plastic, reinforced plastic
It's
fiberglass.
some kind of a polymer.
It's a polymer.
Okay.
And it's hard, it's rigid, good with the ultraviolet lights. It's approved in marine environments. It's Marelon. And but there are a lot of mistakes with those through holes, with those fittings. The people say, oh, because I have in my boat some European boats, for example, Lagoon, for example, Leopard. They say those new catamarans, Leopard catamarans, they are coming with no bonding. Incredible. And today we have the visit of Yoli, other of my previous student. I want that you talk with her. Great person. He is living in the boat with her husband in a Leopard catamaran 44. And he is doing a great job in that boat. He repaired the diesel engine with me, and now he will start to create the solar system with the Victor. It's a nice project. That boat and all the Leopards, they are coming with no bonding. And the argument is because they say that they don't need. Those boats don't need bonding because all the through holes, all the fittings are in Marelon, in plastic. And okay, all right, okay, good. Your through holes in plastic. But what about all the metals inside of the boat?
Exactly.
No, because those metals are not in contact with the water. No, papi. This is a closed element, especially a sailboat. It's a closed element where the electrons are flowing in that area. A lot of humidity, and yes, you have salt water. You have water maker. Yes, I have. Okay, the water maker enters, circulate. You have engines. Yes, I have. Okay. You have air condition. You have a lot of equipment that suction raw water. The raw water circulate, and after that goes out. Not only the through holes. Okay. Excuse me. You have AC panel. You have AC current. Yes, I have a small generator. Okay. You have this. Oh, you have all the conditions to accelerate corrosion. you need a bonding system, no? Of course. If you have metals, if you have current, especially AC current, you need a drain static electricity. You remember? That's the problem. The static electricity is accumulated in the case of the metals and should be drained. Yes, in the boat of, you remember the other guy that visited the class, Christian, with the long hair, you remember him? We did the bonding for the boat. And in the boat of Jolly, we create a bonding for the boat, and now the boat is clean, in good condition. This is very important. The bonding is necessary. For that reason, that course, the course of corrosion, is very, very, very important.
Yeah, but it says that you can use it, all right, plastic through hull in a fiberglass hull only in fresh water.
No, in salt water also. Yeah, salt water. Yeah, we are going to study that. Excuse me?
You mentioned something about marine inspector.
No, this course is for technicians, for engineers. I have a lot of in the past and now in my online academy, I have a couple of inspectors taking my corrosion course because they consider that course valuable for a surveyor, for an inspector. Okay. No, I don't have a program for inspectors. I don't have a program for surveyors. But my courses are loved for those guys. Okay. All right. Okay, we are going to start to refresh a lot of concepts about the use of the tools. But before we start to check the DC panel, the AC panel, I want to finish with the electronic panel with one topic. You remember yesterday, let me turn on this. Until today, you enjoyed the classes, guys?
Yeah. Yes,
Yeah?
sir.
Good? Good, Papa? Angel? Nice, no? All right. Yeah, I love it. I love it when I have captains, when I have older guys like you and me, when I have young people, because it's a good combination. At the end of the day, the younger guys are contaminated with yours. This is a good contamination because they appreciate they appreciate this. I hope. Okay, it's working. All right. Yesterday we talked practically the last part of the bonding of the backbone, the NEMA backbone. You remember that? And we are going to refresh quickly. Don't forget that number should be forever. Maximum length 250. Maximum amount of devices 50 devices. No. The maximum length of the drop lines
6 meters.
6 meters. 6 meters. The total of drop lines 78. You remember, okay, the terminal resistors, 2 terminal resistors, one at the and in each end. How much is the maximum voltage drop?
8
No, this is the
maximum.
amount of amps flowing, especially if you are using mini and micro cables. Excuse me, 3 volts, correct? And how you limit those 8 amps in the backbone with
fuses.
Fuses. Okay, don't forget with fuses. Okay, if I have only one source of power, I need only one fuse of 8 amps. If I have 2 sources, 4 and 4 fuses, amps. Okay, all right. But this is the $1 million question, because the people say, okay, Mr. Lopez, nice that theory. But how I know that I have 8 amps flowing, or 1 amp, or 0.7
Test it, right?
flowing through the backbone? How I know that? How can you imagine? This is the backbone. How can you imagine that you can measure? Only thing I want to do that. I want to check that only if you suggest to me the process. How can you imagine? You are right now in a boat in front of the backbone. And you need know if you have excessive amount of amps or low or zero, or you need measure that.
Remove one of the turbo resistors and
Excuse me?
remove one of the turbo resistors and multimeter.
Okay, we are going to refresh quickly, Dr. Aaron, the process to read amps.
Oh yeah.
Amps. Amps. The terminal resistor is to close the loop. Alright. You remember how is the process to read amps?
Ohms.
So you have to know the talk.
Amps. Amps.
Amps.
What is the process? Number one? Number one? Pin, pin. No? Amps. Number two? This one in amps DC or amps AC. That's okay?
In this case, it's DC.
That's number one. Some people say no. Yeah, I put amps like this, and now I put this one in the positive of the battery and the negative of the battery. Immediately, what happened with the fuse of this?
Low. Short. No.
Bye-bye. Because should be in series. You need interrupt the positive line and read over there. You remember that? Interrupt the positive line and over there. I need cut the cable, and yes, literally yes. But in the real life, you don't cut the cable. Where you can interrupt a circuit
And the breaker.
on the breakers. Where are the breakers? In the panel. No? You remember that? We are going to read how many amps is the consumption of the fan. Let me check where is the fan in this. Yeah, it's the breaker number 3. No? Okay. I select my multimeter in amps. Amps. I put the terminals, the common and the second one in amps. And now I am going to check one terminal here in the positive bus bar, and the other one touching the breaker for the fan. No? In this moment the fan is off. The contacts in the breaker of the fan are open. It's off. With this I am going to close.
Close, yeah.
And of course, I am going to read the amps. 2.3 amps. Nice, no? Okay. I need interrupt the positive because the positive pass from the positive bus bar into the output. This is the output. Going to the fan. I need interrupt the positive, but I close the gap. I close the gap with my AND meter. In this moment, this is the AND meter. Okay. How can you do that in my backbone? I want to know how much amps are flowing in my backbone. I want to know how much amps are flowing in my backbone.
You take off the fuse
Excuse me?
where you have the fuse on the positive line. Is that line?
Okay, on the fuse could be. On the fuse could be. But this is the... What happens if you have 3 sources of power? In each fuse? No, because this is over there, or here. No? I need to know in the backbone how much amps are moving. Dr. Garfield.
I don't know.
Oh, I
It's a
know.
circuit breaker.
No, because we don't have... I have one breaker for the source of power, but I need to know in the backbone. Remember, guys, that in the backbone you have a cable for data and cables exclusive for power. If I use that cable only, the positive and the negative, that cable will be exclusive for power. Yes or no?
Yep.
I have one here. Let me check if I have power. I connect here in the backbone.
Oh yeah.
It's constant power.
Let me check if I have voltage in this cable. I am going to check in between the negative and the positive, and I have 12.5 volts. I have 12.5. That's okay? Okay. Yes, this cable is good. But how can I measure the amps? I have this cable open, that positive open.
You create another cable.
Excuse me, I am going to pass for amps, no? Amps, 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 and I am going to read amps in between this cable, positive, and what is the other positive?
The switch.
Excuse me?
On your switchboard.
No, what happened if I go to the positive of the battery?
Boom.
In between the positive of the battery and the backbone.
No, it's in series then.
Excuse me?
It's like in series. Like that's
It's in
the
series.
same,
Yeah, of course. And this is a real series because it's really here in the backbone.
Okay.
No? I go to the positive bus bar in the panel or to the positive of the battery in the back. And now 0.1 amps. 0.1 amps. It's good. How much is the maximum? Allow it?
3.
8. In this moment it's low because I don't have the motor running, I don't have heavy equipment. 0.1. In this moment, this is the flow of amps in this backbone.
What about the power input in the computer? Can you do that as well from there?
No, over there I can measure the volts,
Just the volts?
just the volts. Remember, this is it's difficult to understand that you need interrupt the cable to read the amps. That's the difficult part.
Okay.
That's the difficult part to understand. It's not in parallel because in parallel I read volts.
That'd be-
So you just make one of those like little jumpers to read
Yeah,
amps?
in any part where I have an open terminal,
Screw that.
I connect my power cable,
Yeah.
and between the positive of that cable and the positive of the breakers or the positive of the battery, I read the amps. And this is the real amps in the backbone.
So like, if you go all the way to the battery, are you not getting any other? Well, you're not getting any amperage from anything else on this battery?
No, because I have a battery dedicated for the backbone. That battery is not shared with other elements.
So in the case that you share with other
Ah,
elements,
in that
share
case,
the
you
switch.
read in between the positive of those breakers,
Okay.
the common, and this one.
Don't worry.
And I
Okay.
connect right now here.
Okay, yeah. 'Cause
But
that
in
was-
this particular example, the battery is dedicated only to the backbone, to the electronics. In some boats, you use the house battery bank.
Yeah.
Ah, okay. No, I am going to use the positive of those breakers, the positive bus bar, and the other end here in the positive of the power cable that I connect here directly.
Yeah.
This is the perfect way, guys.
That one. Yeah,
Nice,
kinda
no?
Easier. Because I was like, the battery wasn't shooting a lot of amp.
Nice. And don't forget in the future, I have an equipment. Doesn't matter if it's the electronics panel or the electrical panel or the DC or AC. No. It's exactly the same. I have a breaker that work 10 minutes and 10 minutes and I need to wait other 5 minutes, turn on the breaker and start again. But suddenly, 15 minutes later, once again. What is the meaning of that? What happened in that? It's a pump. What happened in that the circuit for that pump? What is the problem? Why each 15 minutes the breaker
It's overloaded.
is overloaded for some reason?
There's
Where is the problem?
There's a short chafe wire somewhere.
No? It is from the
Okay.
we're going to think in DC, and after that we are going to think in AC. Suppose that the pump is this pump, that DC pump, okay? Yeah? That pump is running, but suddenly, 15 minutes later, the breaker pops. What happened?
Bad fuse?
Bad fuse? No, not because the fuse work or no work.
Okay.
Bad breaker? It's possible that the breaker is so-so, and when the temperature increase, open. It's possible, but
The wire itself.
I think that the problem is in the pump or the wires. The terminals are corroded, loose,
Okay.
and produce that problem. That's very common. That's number one. Number two, the pump. The winding of the pump is
So.
after some minutes of operation with load. What happened with the winding?
Increase the resistance. Shorts.
And make a short. How can I check the winding of that motor?
Megometer.
Megometer.
With the megometer.
Megger.
The megger. That's okay? All right. That's the process. How can I identify that issue? Disconnect the pump, check with the megger, and verify if the pump is good or not. Okay? All right. If the problem is in an AC motor, the motor is running, but after some minutes of operation, the breaker, I wait 5 minutes, start again, and start again. Other 15 minutes. What is the process in AC?
Clamp.
Okay, if I have a clamp, great, I agree with you. If I have the clamp, where I hook the clamp?
Over the hot
Wire.
In the heart of that pump. Let me check, before I use the clamp, let me check what is the amps, what the amount of amps in the label of the pump. Oh, that pump is 7 amps, 10 amps in the peak when the pump starts, and in operational 7 amps. Let me disconnect the pump. I connect the hook here, and now I activate the pump. Yes, 11 amps, and now a 7.5, 7 amps. That's okay. The pump is good or not good? The consumption of amps is according with the label of the pump.
Yeah, the
Yes.
pump is good.
It's okay. What happens if I hook the hot line in the pump? I turn on the pump and I have 20 amps. And reduce a little and stay in 18. This is the problem. This is the problem. Because the breaker for the pump is 10 amps. The breaker support 18 for 15 minutes. After 15 minutes, finito. Now you understand? In AC, the AC clamp is very important. The AC clamp is mandatory, it's necessary. Where? In the hot. Where? In the hot. Mr. Lopez, why can not using the neutral? My friend, the neutral is the return.
Because you're not getting 100% of the.
Correct.
flow.
Remember, if the motor use 7 amps, you only return 3. No? Use in the hot, the clamp.
Can you use that over there?
That clamp, this clamp, this say that is good for AC and DC. For a small currents, in DC, the clamp is not accurate. It's better the multimeter. Okay. Great?
Yes.
All right. This is why I recommend install in both panels, DC panel and AC panel, ammeters, voltmeters, analog and digital in both panels. Why analog and digital?
In case the digital goes out.
Excuse me?
In case the digital goes out.
No, it's not for that.
Does one try to get frequency?
For example, I have a question. You remember, you installed those gauges, you remember?
Yeah.
Those gauges are good to read 0.7 amps, 0.1 volts. With those gauges, you read 5 volts, 5 amps, higher numbers. With the digital, you read 0.007, 0.003. Yeah? For that reason, I recommend both type of gauge, analog and digital. The same with the gauge. You remember when you did the dashboard, you installed the coolant temperature sensor, the coolant temperature gauge. What other one? Oil pressure gauge and fuel gauge. You remember? I recommend in the engine room. Excuse me. I recommend in the dashboard analog,
Because of the sun.
and in the engine room digital. Some captains, they say, I want both of them here in the console. Okay, install both of them if he needs both of them. I recommend the analog because it's easy. See the needle. If you have too much sun, the needle is over there. The digital, with too much light, in some cases is difficult to read. All right? Both of them in AC panel, in DC panel, and in the dashboard, analog and digital. You are clear about the installation of the gauge, no? It's clear. Now I am going to refresh. The voltmeter in DC, where should be installed? The positive voltmeter, the positive line, where is connected? Where?
Positive bus bar.
The positive bus bar is the common side of the breakers. And the negative? To the negative bus bar. That's for the voltmeter in DC. Ammeter in DC. Ammeter. Ammeter.
You have to interrupt the
Ammeter.
cable.
The current coming from the battery pass for the main fuse. Continue the main fuse and enter in this element. What is this? The shunt. And the current continue into the common positive bus bar. On the side of the shunt, you have two small wires coming into the ammeter. Finito. That's clear? Okay. In the AC panel, in the hot bus bar, in the hot line, you install the donut. And the donut read the amps in the ammeter and digital. In the ammeter analog, exactly the same. The hot line enter in the main breaker. After the main breaker enter in the common hot bus bar. You have one donut here in this and other donut here in this. That's perfect. One for the digital and one for the analog. Right? Amps in AC with donut. Finito. Don't forget that. The donut is exactly the same like
The clamp.
The clamp.
is the clamp. It's exactly the clamp. The donut is the clamp. Good, no? All right. Great. And the frequency meter in AC is in parallel with the voltmeter. Hot and hot, neutral and neutral. You remember? And the procedure to read hertz, to read frequency with the multimeter, you remember that? How is? What is the process?
You just press the button.
What is the process to read amps? To read amps? To read hertz in AC current, guys?
Just push it into the holes and then you press
Dr. Garfield?
frequency.
Okay, what is the process? You set the voltmeter, the multimeter in what? In volts, in amps, in what?
In volts.
Volts. Volts AC. No? And after that, we are going to read the volts. How much?
0.8, 1.
Volts AC.
Well,
123.
120.
123. No? 123. And what is the process to read frequency?
Just press the yellow button.
You press the second function, yellow one. How much is the frequency of this building?
60.
60 amps. You see?
60 hertz.
60. That's good. Nice, no?
Yeah.
Is in volts. Okay, great. 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 Volts AC, and you switch for frequency, and you have the frequency. For that reason, when you connect the gauge for frequency, is hot with hot, neutral with neutral, in parallel with the voltmeter and frequency meter. In some generators, you have frequency meter and RPM. Remember that the frequency is directly related with the RPMs. More RPMs, more frequency. Is another gauge for RPMs in parallel with the frequency meter. Okay? Finito. Good?
Yep.
All right, great. You like it, the procedure to read the amps in the backbone? This is a very, very common situation in the backbone. Other common situation is that you need you need verify capacitors, no? And you need verify the condition of the galvanic isolator. Okay? How you check the capacitors? Can you refresh me quickly? How is the process to check capacitors?
You